In this lesson, we're going to find the domain and range of a quadratic function. Before we begin, let's go over some key terms. So starting with the domain refers to the set of input values for a relation or function. It's your x values. So in other words, if you have a function, the domain would be all the allowable values that you can plug in for x and it'd be okay without violating anything. And your range, it would then be the set of output values for a relation or function. In this example, we're asked to identify the domain and range of the given quadratic function. So here we have the function f of x equals x squared minus 3, which is nothing more than the parent function, which has been shifted down 3 units. Now let's focus on the domain. Recall that the domain is your set of x values, your input. And so basically in terms of a graph, we just want to know the horizontal span. In other words, how far does it stretch to the left or to the right? Because you have a parabola with arrows on both ends, this parabola from left to right, it's going to be moving to infinity, and infinity to the left and infinity to the right. So we would say that the domain would be from negative infinity to positive infinity, again because we have the arrows on both ends, which indicates that it will extend to infinity in both directions. Next, we want to focus on the range, which is your output or your y values. So in other words, in terms of a graph, this will be the vertical stretch or the vertical span of this graph. So notice that this parabola has a minimum. The lowest point that this parabola will drop would be -3. So our graph will extend from -3 and it will continue to go all the way to positive infinity. And so the way we would write that in interval notation would be brackets -3 comma infinity close parentheses. Recall, infinities are always closed with a parentheses. And that is the domain and range of this function. Let's identify the domain and range of the given quadratic function. Let's start with the domain, which is the horizontal stretch or span of the graph. And note the fact that we have arrows on both ends up to the left and right means that it is going to extend forever to the left and forever and ever to the right. So we would say that the domain is from negative infinity to positive infinity. And recall that we always close infinities with a parentheses if we're writing it in interval notation form. Next, we want to identify the range. The range is your vertical span. In other words, you want to know how far does this graph extends up and how far it extends down. Note that this graph in particular will begin at 2 and go forever down to negative infinity. To write that in interval notation form, we would write it as parentheses negative infinity, comma, 2 bracket. And that is the domain and range of this quadratic function. In this next example, I'd like for you to use the graph to identify the domain and range of the given quadratic function. So, what is the domain of this function? In our last example here, we're going to identify the domain and range of the given quadratic function. We are given the function f of x equals 2x squared minus 4x plus 5. So the domain, how far does this graph extends to your left and to your right? The span horizontally? Well, because you have arrows there on both ends, that indicates that this graph is going to go forever to the left and forever and ever to the right. So in both directions, it's going to be moving toward infinity. So therefore, we say the domain is from negative infinity to positive infinity. What about the range? Well, as we can see, the range, which refers to the vertical stretch of our graph begins at, it has a minimum point there at 3. It will not go below 3. So it starts at 3 and then it just goes forever and ever up to positive infinity. And so the way we would write that then would be brackets starting at 3, comma, and then going to positive infinity, close parentheses. And there you have it, the domain and range of a quadratic function. Okay, that's it for this video. Thank you for watching MVP tutorials created by your instructor, Dr. Speights. Please feel free to like, share, and subscribe. Goodbye for now. I hope you'll join me in the next video.